Alex here from Math Magicians, and we will continue with our physics course. For this video, we will start discussing what displacement and velocity. And our first topic would be motion. Motion is something that happens all around us every day. Every day we see objects move in different directions with different speeds. One-dimensional motion is the simplest form, as you can see here, of motion. One way to simplify the concept of motion is to consider only the kinds of motion that takes place in one direction. An example of one-dimensional motion can be the motion of a train on a straight track. In this type of example, a train can only move forward or backward, but the train cannot move from left to right. Let's define now what is a frame of reference that you see it here. Frame of reference is a system for specifying the precise location of objects in space and time. When physicists are faced with complex situations, they break it into simpler parts. You can choose a frame of reference at which you can measure changes in position. One very good advice is that when you choose a frame of reference, note that it remains fixed for the problem in question and has an origin or a starting point from where the motion is measured. This leads us to the next subtitle that you can see here, displacement, this one here. Displacement is the change in position of an object. As any object moves from one position to another, the length of the straight line from its initial position to its final position is called displacement. You can see the formula for position here, which says delta x is equal to final position minus initial position. Don't forget that delta means change. Let's answer these two questions that you see here. It says, a space shuttle takes off from Florida and circles Earth several times, finally landed in California. While the shuttle is in flight, a photographer flies from Florida to California to take pictures of the astronaut when they step off the shuttle. Who undergoes the greater displacement, the photographer or the astronaut? Remember that both landed in the same place. That means that neither, because their displacement would be the same. The next question says, what is the difference between the displacement of the photographer flying from Florida to California and the displacement of the astronaut flying from California back to Florida? The only difference that they would have would be their direction. One would have to be a positive direction and the other one has to be a negative direction. This leads us to the next part of the video. Displacement can be positive or negative, as you can see described here. Positive displacement, an example is when you're moving to your right, or in this case, to the east. I'll draw it here. This will be your east, your north, your west, and your south. So when you move to the east or to the north, you will have a positive displacement. Backwards, when you move south or to the west, your displacement will be negative. Let's continue with velocity now. Average velocity is the total displacement divided by the time interval during which the displacement occurred. You have a formula here. It says the average velocity is equal to the change in your position, in other words, final position minus initial position, over your change in time, that in other words would be your final time minus your initial time. And let's continue with the next part that leads us to the first exercise. It says, during a race on level ground, Andrea runs with an average velocity of 6.02 meters per second. This is your average velocity, and it says that it's moving to the east, indicating that it's positive with 3 significant figures. Then it says, what is Andrea's displacement after 137 seconds? Okay, so they give you your time. Your change in time is equal to 137 seconds. What am I looking for? I'm looking for my change in position. My formula stated that my average velocity, let's use it with another color. Let's use this color. Your average velocity is equal to, let's write it down here. Your average velocity is equal to your change in x over your change in time. If I am looking for my change in x or my position, I have to change this time to this side as a multiplication. That means that my change in displacement is equal to the multiplication of my average velocity times my change in time. If I substitute the information, my average velocity said that was 6.02 meters per second. And my time is 137 seconds. 137 seconds. If we make this multiplication, your answer is 824.74. But because remember that we already know what significant figures are, when you multiply, you take the amount of the lowest amount of significant figures. That means that we're just going to use 3 significant figures. Your change in displacement would be 825 meters. Now, why meters? We saw that also in conversions. If I have meters over seconds, that is my velocity, and I have in the other side just second, that is your time, and you simplify, you get stuck with this amount of meters. With this, we will continue with the next one. Okay, continuing with our video, it says, Simpson drives his car with an average velocity of 48.0 kilometers per hour to the east. Again, our velocity is positive, and it says that it's 48.0 kilometers per hour. How long will it take him to drive 144 kilometers on a straight highway? How long? That would be your time. That's what you're looking for. And the displacement says that is 144 kilometers. Okay, now we're looking for time. Our formula said our average velocity is equal to our change in time, our change in x over your change in time. If I am looking for my time, what I do is that I just switch these variables, indicating that my time is equal to my change in x over my velocity. And then you substitute. You have time is equal to, your change in x is 144 kilometers over your velocity, or your average velocity is 48.0 kilometers per hour. We know that we simplify our kilometers. My final answer will just be in hours. And we're going to find it with 3 significant figures. Calculate. It says that it's 3 hours. Since we need 3 significant figures, it will be 3.00 hours. This would be your answer. With this, we'll continue with our next slide. The next one is another type of example. It says a bus travels 280 kilometers south, negative, along a straight path with an average velocity of 88 kilometers per hour to the south, also negative. But the bus stops for 24 minutes, then it travels 210 kilometers south with an average velocity of 75 kilometers per hour to the south. As you can see, everything is negative here. Then he says, the first question, how long does the total trip last? Okay, so our givens are my displacement, let's call it 1. It says that it's negative 280, let's fix this here, kilometers. Let me just fix this here, kilometers, there you go. Then you have an average velocity, we will call it average velocity 1, that is negative 88 kilometers per hour. You also have another displacement. The other displacement says that it's 210. We'll call it displacement 2, and it's also to the south, so it's negative 210 negative kilometers. And you have a second, because the bus stops and then continues, it says that it's negative 75 kilometers per hour. And don't forget that the bus stops for 24 minutes because you're going to need that also. So the first question says, how long does the total trip last? We need to find our time 1 and our time 2. And we already said that time is equal to delta x over velocity. We just need to substitute. My time 1 is equal to my delta x, that is negative 280. Remember that is kilometers per hour, over negative 88. Your answer for your time 1 is 3.19 with 3 significant figures of an hour. Then the time 2, you just substitute the information that you have here. So it says that it's negative 210 kilometers per hour over 75 kilometers per hour. If you, this one is negative also. If you divide this, your answer is 2.80 hours. Then, don't forget you had 24 minutes. So, we have to make the conversion of these 24 minutes into hours. Okay, why? Because our two answers here were left in hours, and it's easier to convert one to hours than the other two to minutes. So, we know that 1 hour has 60 minutes. We cancel our minutes, we make our division, it will be 0.40 of an hour. Okay, now what are we going to do to find my total time? Or my answer for letter A is add all this. If you add all of them, it says that it's 6.4 of an hour. This will be your answer for letter A. We'll continue now with the next one. It says, what is the average velocity for the total trip? Okay, for the total trip, we have to make an addition of this information. And let's continue with another slide. Okay, so my total displacement is equal to negative 280 plus negative, let me fix this, plus negative 210 in kilometers. Your total displacement is negative 490 kilometers. Your time, we found it already, that was 6.4 hours. Okay, the average velocity is equal to delta x, that in this case is negative 490, sorry, over your delta time, that is 6.4. If you make your division here, it will tell you in two significant figures that is negative 77 kilometers per hour. Because it's negative, we can say that it's 77 kilometers per hour to the south. And that would be your answer for this exercise. This leads us to the next part of the video. Velocity is not the same as speed, and velocity can be interpreted graphically, as you can see these three graphs. They are called position time graphs. The motion of an object moving with constant velocity will provide a straight line graph of position versus time. The slope of the graph indicates the velocity. It would be for this type of graph. For the second type of graph, where you see three objects, okay, object 1 moves with constant positive velocity, object 2 is at rest, and object 3 is moving with a constant negative velocity. And that instantaneous velocity may not be the same as average velocity, because instantaneous velocity is the velocity of an object at some instant or at a specific point in the object's path. As you can see here, a specific point in the object's path. The instantaneous velocity at a given time can be determined by measuring the slope of the line that is tangent to the point on the position versus the time graph. Okay, so that would explain your position time graphs. And as always, here are some practice problems. The answers will be posted in the next video. And don't forget, physics is life.